There are two formulas for calculating the sum of a geometric sequence, which is called a geometric series. What we're going to do here is we're just going to try to derive those two formulas. So in other words, I'm just going to try and show you where those formulas come from. The first thing I'm going to do is just write out Sn. So S stands for sum, n is the number of terms we're going to add up. So because it's a geometric sequence we're adding up, I know the first term is going to be a, and then I'm just going to multiply by r to get each of the next terms. So it's going to be a plus ar squared plus ar cubed plus etc., until we get to ar to the power of n minus 1, which is tn. So term n is the last term we're going to add on. What I want to do is I'm going to multiply that whole line by r. So I'm going to go r times Sn is going to be, well, if I go r times a, I get ar. And then I'm going to go r times ar, I get ar squared. R times ar squared is ar cubed, etc. And eventually I get everything, including ar n minus 1. But then when I go r times ar to the power of n minus 1, well, it's r to the power of 1 times r to the n minus 1. Add the exponents. 1 plus n minus 1 is just n. So on that bottom line, it's just ar to the power of n. Okay, now I'm going to subtract r times Sn, that whole bottom line, from the top line. So just going straight down, if I subtract Sn minus r Sn, can't really do anything, so I'm just going to leave it that way. A minus nothing is just a, but then as I go to the right, everything cancels until we get to ar to the power of n. So Sn minus rsn is a minus ar to the power of n. Now we're just going to solve this for Sn. So factor Sn out on the left, and on the right, factor out the common factor a. Divide both sides by 1 minus r, and this is one of our two formulas for the sum of a geometric series. Is Sn equals a times 1 minus r to the n over 1 minus r. Now to find the other form of the equation, what I'm going to do is I'm basically going to start at the start again, just with the Sn factored out. So I'll have Sn times 1 minus r equals a minus ar to the power of n. What's important to remember is that ar to the power of n comes from r times tn, right? We went r times ar to the power of n minus 1. So then that a minus ar to the power of n is really a minus r times tn, which I can divide both sides by 1 minus r, and I get a minus r times L over 1 minus r. So what that L actually stands for is Tn. So sometimes this equation is written as a minus r times Tn over 1 minus r, or a minus rl over 1 minus r, where L means last term. Okay, all of this derivation, you don't actually have to memorize or know any of this. This is just for interest's sake, so you know where these formulas come from. But in the next little bit, we're going to talk about when to use each, and that's what's really important. So you just have to know how to use these two formulas. You don't have to know where they came from. Okay, so the first formula, Sn equals a times 1 minus r to the n over 1 minus r, I always use that if I know how many terms are being added up. So if we're adding 30 terms of the geometric series, then this is the formula we're going to use. The second formula, Sn equals a minus rl over 1 minus r, I use that if I don't know how many terms are being added up, but I know what the last term being added is. So if you know that last term, you don't need to know how many terms you're adding up, which is nice. If you did this before with arithmetic series, you always had to know how many terms are being added up. With geometric, you don't. We got one formula if you know how many terms, and one formula if you don't know how many terms.